The fabric of space and time funnels you, yes, so that in fact you're occupying a narrower and narrower cone of space, so you're getting extruded through the fabric of spacetime. The James Webb Space Telescope has spotted giant black holes all over the early universe. The astronomical community is in a state of disarray due to this mind-blowing discovery. Renowned scientist Neil deGrasse Tyson speculates that this extraordinary telescope may have caught a glimpse of something never seen before, black holes from an earlier universe that may have seeded our own. This discovery calls into question our very foundational theories about the universe, including the Big Bang. How is it that a bewilderingly vast population of violent galaxies, with massive black holes at their centers, call our young universe home? Has our understanding of the cosmos been completely incorrect the whole time? Join us as we explore how the Webb telescope saw the black holes of the previous universe that created our universe. Christina Iser began organizing a symposium for early universe astronomers years before she was certain the James Webb Space Telescope would launch successfully. She knew that if, preferably when JWST started making observations, she and her colleagues would have a lot to talk about. In comparison to earlier instruments, the telescope could look farther into the distance and further into the past, making it function like a time machine. Thankfully, Iser's preparations were not in vain. It had been more than a year since JWST began transmitting photographs to Earth, and the telescope is already changing how astronomers thought about the first billion years of the universe. Out of all the presentations, one group of mysterious objects jumped out. Some astronomers called them hidden little monsters, to others, they were little red dots. But whatever their name, the data was clear. When JWST stares at young galaxies, which appear as mere red specks in the darkness, it sees a surprising number of cyclones churning in their centers. A deluge of sightings of the cosmic smudges in the past few months has both thrilled and puzzled astronomers. The simplest theory to explain the galaxies with tornado shapes is that massive black holes with masses comparable to millions of suns are causing the gas clouds to spiral out of control. That result is expected, but also puzzling. It is to be anticipated, as one of the purposes of JWST was to discover these ancient objects. They predate the mysteriously early appearance of billion-sun monster black holes in the cosmic record. 3 record-breaking youths found these precursor black holes this year. By studying them, scientists want to learn about the origins of the first massive black holes and maybe determine which of 2 competing theories, that they were born large or that they grew very quickly, is more accurate. Surveys are revealing young ravenous black holes by the dozen, which is surprising and confounding because astronomers did not anticipate JWST to discover such a large number of them. Astronomers have discovered a swarm of massive black holes while trying to explain the first riddle. This discovery might reshape long-held beliefs about stars, galaxies, and other cosmic phenomena. The James Webb Space Telescope supplies the essential background information for galaxies at unprecedented distances by analyzing their spectra, which show the composition and activity of the universe's atoms. The enormous black holes that hide at the center of galaxies can be located with the help of galactic spectra, which are ideal for detecting this atomic perturbation. Although black holes don't appear to be very colorful at first glance, the atoms they consume produce visible light as they burst apart. Astronomers had high hopes that JWST would reveal these patterns and locate enough massive active black holes in the early cosmos to explain their formation. Long before the observatory was even launched, the riddle started almost 20 years ago when a group headed by Fan discovered a dazzling quasar, a galaxy attached to a very active supermassive black hole that could be billions of suns in mass. It had a redshift of 5, corresponding to around 1.1 billion years after the Big Bang. With further sweeps of the sky, Fan and his colleagues repeatedly broke their own records, pushing the quasar redshift frontier to 6 in 2001 and eventually to 7.6 in 2021, just 0.7 billion years after the Big Bang. Creating such massive black holes appeared to be an insurmountable task at that early stage of cosmic history. Black holes, like any other object, require time to expand and shape. The universe wasn't old enough for Fan's supersized black holes to have accumulated billions of suns of weight, making them too huge for their age, like a 6-foot-tall toddler. Two unsavory possibilities were presented to the scientists as explanations for those children who had grown too big. The first was that, like most galaxies, Phan's galaxies began with regular black holes around stellar mass, like the ones left behind by supernovae. Afterward, those expanded by merging and absorbing gas and dust from their surroundings. A typical scenario is that a black hole will be pushed away from its food supply by a radiation shower. Scientists refer to this limit as the Eddington limit, and it puts an end to the feeding frenzy. A continual deluge of dust may theoretically counteract the deluge of radiation, but this is only a soft ceiling. But it's hard to believe that Phan's animals could have maintained such super Eddington growth for an extended period of time. They would have needed to gain weight at an unfathomably rapid rate to account for them. In contrast, it is possible for black holes to be unusually massive when they form. Heavy seeds formed when gas clouds crashed into black holes the size of hundreds of suns may have existed in the early cosmos. Such a scenario is also difficult to fathom because before merging into a black hole, such massive clumpy gas clouds ought to burst into stars. By looking back in time and capturing the fainter progenitors of Phan's galaxies, JWST hopes to assess these two possibilities. Although these galaxies would eventually become quasars, they would still be on the path to becoming smaller black holes. With JWST, scientists have their best chance of spotting black holes that have barely started to grow, objects that are young enough and small enough for researchers to nail down their birth weight. That's why, in the days after Christmas, a team of astronomers working on the SEERS survey, led by Dale KVY of Colby College, started putting in extra hours when they began to discover indications of such newborn black holes. Appearing a handful of galaxies stood out in the SEERS spectra as possible hiding places for the diminutive monsters, baby black holes. These galaxies' light didn't come in a single clean hue for hydrogen, unlike their less exotic counterparts. Rather, the hydrogen line became a patchwork of colors, suggesting that the light waves were compressed as gas clouds in orbit hurried toward JWST, like an ambulance's rising wail when its siren sound waves are compressed and stretched as clouds in orbit departed. In the opinion of KVY and his colleagues, black holes were the sole objects that could hurl hydrogen in such a way. A preprint explaining two of the hidden little monsters, as they were dubbed, had been produced by the SEERS team by the end of January last year. The team then proceeded to examine a larger sample of the hundreds of galaxies gathered by their computer in an effort to quantify the number of black holes in the universe. But they got scooped by another team led by Weiichi Hirain of the University of Tokyo. Just weeks later at redshifts ranging from 4 to 7. Hirain's team discovered 10 out of 185 faraway SEERS galaxies with broad hydrogen lines, which are most likely the result of central black holes with a million solar masses. Jorrit Matthey of the Swiss Federal Institute of Technology Zurich led an investigation of two further surveys in June, which revealed 20 additional little red dots with broad hydrogen lines. These were recognized as black holes whirling about redshift 5, another dozen were reported in an analysis published at the beginning of August. Some of these may even be combined to increase their size. However, the abundance of galaxies containing massive, actively rotating black holes caught astronomers off guard. The baby quasars in JWST's first year of observations are more numerous than scientists had predicted based on the census of adult quasars, between 10 times and 100 times more abundant. However, astronomers are aware that they will need to probe further into the first billion years of the universe and push beyond redshifts of 5 if they want to see the creatures in their infancy. Recently, several teams have spotted black holes feeding at truly unprecedented distances. A new record for the most distant active black hole ever identified was set in March of last year when a SEERS investigation, spearheaded by UT Austin astronomer Rebecca Larson, found a broad hydrogen line in a galaxy at a redshift of 8.7, 13.7 billion years after the Big Bang. Unfortunately, Larson's record was quickly surpassed a few months later when scientists from the JADES group obtained the GNZ11 spectrum. Scientists were keen to explore GNZ11 with sharper eyes because it had been at the weakest edge of the Hubble Space Telescope's vision at redshift 10.6. According to John Schultz, a JADES member from the University of Cambridge, its nitrogen abundance was totally out of whack. The abundance of nitrogen in a young galaxy was reminiscent of encountering a 6-year-old with a 5 o'clock shadow. This was particularly true when contrasted with the sparse oxygen reserves of the galaxy, a more basic element that stars are supposed to produce initially. The JADES collaboration followed up with another 16 or so JWST observing hours in early May. The spectrum was refined by the extra data, which showed that the two visible nitrogen shades, one very strong and one very weak, were highly uneven. The group concluded that the pattern pointed to a terrifying gravitational force concentrating gas clouds on GNZ11. At that moment, it hit us. We were peering directly into the black hole's accretion disk. That lucky alignment clarifies why Hubble was able to see the faraway galaxy in the first place. Astronomers had hoped that objects like GNZ11, which are extremely young and ravenous black holes, might provide light on the mystery of the origins of quasars. Surprisingly though, not even the exceptional GNZ11 is tiny enough or young enough for scientists to establish with certainty what the star's birth mass was. Neil deGrasse Tyson argues that we must begin to discover black hole masses at redshifts far greater than 11. Until then, astronomers are resorting to more subtle tricks for finding and studying newborn black holes, tricks like phoning a friend or another flagship space telescope for help. A group of astronomers, headed by A.O.S. Bogdan of the Harvard-Smithsonian Center for Astrophysics, began intermittently directing NASA's Chandra X-ray Observatory towards a cluster of galaxies that they anticipated would be considered for JWST in early 2022. Like a lens, the cluster focuses light. The farthest galaxies behind it are magnified as it distorts spacetime. As X-ray emission is a classic signature of a devouring black hole, the group hoped to determine whether any of the background galaxies were emitting them. During its longest observation campaign to date, which lasted 2 weeks and lasted over a year, Chandra detected 19 X-ray photons emanating from a galaxy known as UHC-1 at a redshift of 10.1. The 19 high-energy photons were presumably emitted by a black hole in its early stages, making it the most distant X-ray source to date, occurring less than 500,000 years after the Big Bang. The team discovered something peculiar and useful. By merging the JWST and Chandra data sets, almost all of a modern galaxy's mass is contained in its stars, with only a small fraction contained in the core black hole, contrary to what astronomers would anticipate for super-Eddington accretion. Mass in UHC-1 appears to be evenly distributed among stars and the black hole. The group proposed a more reasonable theory, which holds that the central black hole of UHC-1 formed when a massive cloud collapsed into a massive black hole, resulting in the loss of much of the gas necessary to form stars. All of these findings could be consistent with a heavy seed. It's crazy to think about these giant balls of gas that just collapse. Although the precise quantities and characteristics of each item are yet unknown, the overwhelming evidence suggests that a significant number of accreting black holes have been discovered. The fact that JWST has finally unveiled them is thrilling. This is a long-awaited discovery for those who study black holes. Active black holes in young galaxies were recently suggested to be missed in studies of chaotic teenage galaxies in the current cosmos. Also, theorists have had a tough time since in their computer simulations, they kept getting worlds with many more black holes than what astronomers were actually seeing. Since supermassive black holes are now being understood as more than mere cosmic cameos in an expanding universe, astronomers are starting to wonder if giving these objects more substantial theoretical roles could solve other problems. Astronomers were quick to notice that some galaxies appeared abnormally massive compared to their apparent age. After examining early JWST photos, however, in certain instances, researchers may be led to overestimate the mass of the nearby stars due to a glaringly luminous black hole. The star formation rate, which is often overestimated in galaxy simulations, is another idea that might need some fine-tuning. During their hidden monster phase, many galaxies, according to KVY's speculation, undergo a star formation slowdown. During this phase, the galaxies begin as cocoons of star-crafting dust, but as their black hole becomes more powerful, it scatters this material into space, delaying star creation. We may be considering that scenario as a possibility. There are a lot more newborn black holes that scientists and telescopes need to find. More so, ever since astronomers first laid their eyes on the sparkling spiral arms of our home galaxy, the Milky Way, they have wondered what processes might drive the evolution of these massive star-studded structures. The observable universe comprises an estimated 2 trillion galaxies with unique sizes, shapes, and compositions. The remarkable diversity of galaxy neighbors is likely explained by those same processes. So, in an effort to further our understanding of galactic evolution, over 100 astronomers from over 80 institutions around the world have called for the James Webb Space Telescope to conduct a multi-epoch large-area multi-wavelength survey of the Milky Way's innermost regions. Understanding the dynamics in the galactic center, the beating heart of our Milky Way, should provide insight into the workings of the vast majority of galaxies in the cosmos. Despite the fact that the galactic center of the Milky Way has been the subject of much study, many astronomical questions about it remain unanswered. The function of the supermassive black hole in our galaxy's evolution is one area of interest for astronomers. In the nearby chilly dark molecular clouds, why is star formation in our galaxy taking longer than expected? When did the central star clusters of our galaxy begin to form? The team's idea proposes utilizing a multitude of other telescopes, both old and new, to bolster the JWST discoveries, because even with all that, a single telescope couldn't discern the complete picture. The survey is set to incorporate not only the currently operational Atacama Large Millimeter Array and the Hubble Space Telescope, but also future telescopes such as the Roman Space Telescope, the extremely large telescope of the European Space Observatory, and Japan's Jasmine astrometry satellite. Data on the galactic center would be collected at 1, 5, and 10-year intervals by the proposed multi-epoch survey. What could we learn concerning the Milky Way? One of the most significant mysteries is the nature of its black hole, Sagittarius A*, and how it affected our home galaxy's evolution. It is well known among astronomers that accretion disks, which are shaped like plates, contain gas surrounding huge galactic black holes like this one. It is plausible to assume that the pace of star formation in the galactic center is related to the growth history of Sagittarius A*, as the existence of this gas is likewise an ingredient necessary for star formation. The proposed multi-epoch observations of the galactic center should give astronomers a solid idea of how many stars are forming and, therefore, the rate of growth of Sagittarius A star. The fact that Sagittarius A** doesn't seem to be consuming a lot of material suggests that it isn't an active black hole, as active black holes release a lot of electromagnetic radiation. An important hint in the scenario is that Sagittarius A** is what astronomers call a quiescent black hole, meaning it is essentially inactive. The initial mass function is tricky to measure, though, because the brightest stars go supernova in a very short time, so they're not around for long enough to measure. Since it contains numerous stars of varying masses, the galactic center presents us with a great chance to overcome this obstacle. Furthermore, it is a different enough environment than the solar neighborhood that we learn something new about how to apply star formation rules to other galaxies. The Milky Way's galactic center is the only galactic core we can observe where each star can be investigated individually, and the more we learn about our galaxy, the more we will learn about how other galaxies evolve throughout the universe. The scientists want to take us on a journey from galactic suburbia to the city center, where a bustling metropolis full of mystery awaits. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.